All right, good morning, guys. In today's class, we'll be advancing our database lessons. So we have so far completed the first chapter and the second chapter in database. So we'll be going towards in the interactive tutorials. Today we'll be covering SQL lesson 3 and lesson 4. This is queries with constraints and filtering and sorting queries. So basically we'll understand how we can actually sort them or how we can filter them as per our needs. So this is in lesson 3 and lesson 4. But before jumping into that, I would like to give you a basic idea about set theory. This is quite important for you to understand. So set theory, it will be inaccurate if I tell that set theory is exactly related to database. But if you understand set theory well, it will be very easy for you to relate and work with databases. So today we are going to see the introduction of set theory. So these are very simple concepts. A set is defined as a collection of elements. A collection of elements or objects. So, for example, a set is represented with a capital letter. A can be 1, 2, 3, 4. What does this mean? So, the numbers 1, 2, 3, 4, these four belong to the set A. It can also be written as 1. This is not E, but this is a symbol of belongs to A. 2 belongs to A. 3 belongs to A. 4 belongs to A. So don't get confused here. So set is nothing but a collection of objects, and they are represented by this flower brackets or flower parentheses. And this symbol is nothing but belongs to. It is not E, it is belongs to. So another set has, let's say, B is equal to S, M, P, I. Just for random variables. Now you can write it as A does not belong to set B, because A is a variable which does not exist in the set B, but I belongs to set B, right? So this is a basic understanding of set and how they are represented. So you have three different types of sets, or actually four different types of sets. We'll be going through each and every set in our next tutorial, but in this one you'll just know what are the four categories. So one is called a universal set. The second one is called a subset. Third one is called a power set. The fourth one, the final one, is called null set. It is represented as 5. So this is called PHI 5. So this is just a name for null set 5. So these are the four different sets that we'll be learning throughout this particular topic, set theory, right? Now, the important concept that I want you guys to learn today is called cardinality. Let me explain you what cardinality is. This is something that you will be using in databases, especially in today's lesson in 4.3. So do note this down, cardinality. Cardinality means, for example, let me start with an example. If I'll have A is equal to 1, 1, 6, 6, 8, 8, 15, 15, 15. If this is an example for you, cardinality says A is nothing but you will not consider the elements that are repeating. So the actual answer would be 1, 6, 8, 15. You will ignore the terms that are repeating and you will only write one of them, right? So this process or this phenomena is called cardinality, writing the distinct elements. Distinct elements. And don't get confused that elements, when I say elements, it is only numbers or variables. Elements can be, they can be numbers, any kind of numbers, real numbers, complex numbers, natural numbers, whole numbers, integers, rational, irrational, any kind of numbers, right? They can be variables, they can be terms, they can be mathematical expressions, they can be words as well, like nouns or any kind of words. You can write your names, you can write anything when we are talking about elements. But in a set, you must always have distinct elements. So distinct is the keyword. That means you cannot repeat the same noun or same number multiple times in a set, right? So that is called cardinality. This function is called cardinality. So in database, if you want to have unique numbers or unique or which are not repeating, so you will be using this distinct as a keyword. That is something that we are going to learn today. Distinct as a keyword. So remember this. Distinct is a keyword that you can use it in database to actually get all the variables or all the numbers or all the nouns or whatever elements that you have to be unique, to be distinct. Like how you have mathematical operations, right? Like exponents, squares, roots, or addition, subtraction, multiplication, division. You also have certain type of operations in set. So take down the heading as set operations. In set operations, you have something called union, intersection, complements, and then finally Cartesian products. So these are the 4 set operations that we will be learning in our next tutorials. Okay, so this is just to give you a basic idea of what set is and how set operations are, and what is the keyword distinct and what is cardinality. But now, if you want to represent a set, if you want to represent a set pictorially, that's when you get the new concept called Venn diagrams. People, when I say when, people think it's WHEN. In fact, it is not WHEN. It is VENN, Venn diagrams. It is named after a great scientist, mathematician, I mean. Venn diagrams. What are Venn diagrams? Venn diagrams are used to pictorial representation of set or sets. So for example, I'll just show you an example and then we'll go to database. Okay, we are not going to go detailed into Venn diagrams for this tutorial, but in the next tutorial, we will be learning about union, intersection, and complements by using Venn diagrams. After that, we'll be learning about Cartesian products. So a universal set, we haven't learned the definition yet, but just understand the representation, then you will easily understand what the definition is. A universal set can be sometimes represented as U or mu. It's totally up to you, like however you want to represent. A universal set is U, and it has certain number of elements, and it has two set A and set B. So for example, let us say U is starts from negative 1, 0, 1, 2, 3, 4, 5, 6, 7. Right? This is U. And when I tell A is nothing but 0, 2, 4, 6. Yeah. B is 1, 3, 5, 7. Now you see that A and B does not have anything in common. So A, B. So but I created an overlap over here, and this is something that both of them, if they share anything in common, that usually comes here. But in this example, we don't have anything in common between A and B. So that's the reason A, I'm going to write it as 0, 2, 4, 6. This is A. The one that I'm highlighting with blue is A, but this does not have anything in common. So that's the reason they're not sharing. A and B are not sharing anything, right? But in fact, if you see B is 1, 3, 5, 7. So is this the complete Venn diagram? No, it isn't, because you have covered 0, 1, 2, 3, 4, 5, 6, 7, but you haven't written now negative 1, because negative 1 does not belong to A nor B. So that's the reason this negative 1 is going to be in your universal set lying over here. So U has all of these elements. A has only 0, 2, 4, 6. B has only 1, 3, 5, 7. And negative 1 belongs to the universal set, but it does not belongs to A or B. Okay, let us do one more example to get a better idea of how this works. So this is example 2. Universal set starts from, let's say, negative 0.5, 0, 0.5, 1.5, 2.5. So these are the numbers. A has 0, 0.5, 1.5. Separate them with commas. B has negative 0.5, comma 0. But now if you notice that 0 is something that is being shared by both A and B, right? So now when you draw the figure, so let me draw A as orange, B as blue. I'll name this as A, I'll name this as B. Now if you see, A has 0, 0.5, 1.5. But B also has 0. So I'm going to write something in common. These both things have something in common, that is 0. Okay. Now I have written 0 in A and 0 in B. So what is remaining in B? B is remaining only negative 0.5. But A has 0.5 and 1.5. So by seeing the figure, you can tell that A has 0.5, 1.5 and 0, but B has only 0 and 0.5. And this is your universal set. But there is something missing. We have covered this one, this element and this element, but this element is missing. That means this element belongs to your universal set. That is 2.5 will be outside the circle but inside the rectangle. So this is a representation of Venn diagrams. Understanding Venn diagrams will give you a clear idea on how a lot of things work in database. And when we'll be learning about joins, inner join, outer join, that's when you can relate a lot of things from Venn diagrams, and you can actually do better in understanding and learning database. Now, let us jump to our SQL lessons. So I'll be leaving the link in the description, and both in YouTube and in your classroom. So you guys can actually go through this and read this. Like in the lesson 2, we started or we understood how we can actually perform and get certain numbers, like how do I get only row with ID. So this is taught in your previous tutorial. So we'll not worry about this because you guys can go back to the other video and then review it. But now we are going to start lesson 3. In lesson 3, we are going to use a where clause, and then we are going to find out all the movies as per the questions. Find all the Toy Story movies. If you have to find all the Toy Story movies from this particular table, so you need to understand that all of these are elements, right? So each one of them is an element. So, but you remember this is called an entity, and ID, title, director, year, and length underscore minutes is called attributes. So here you need to find an attribute that is title, and the title has a particular clause that we need only Toy Story movies, right? So instead of select star from movies, I'll do select title from movies to get all the titles, but we need only Toy Story movies. So for that, where I'll write where title. Here you see, I need to use like ABC because I'm trying to compare with all of those things, and I need to use this percentage sign used anywhere in the string to match the sequence because I have Toy Story 1, 2, 3, or maybe 1 and 2. So I need to get only these three things. So that means I need to use both like and percentage sign. So for that, I'll write title like Toy Story percentage, where title like Toy Story, select start from movies where oh, Toy Story percentage. I need to give the space between toy and story percentage and then close it. Now you got all the Toy Story movies. Now if you want to find the director of all the Toy Story movies, you just put title director. So you get the director's names from the table only. If the information is not in the table, you will not get that. And then if I want to see when these movies got released, so when I click here, so you're going to get title, director, year from this movies. Now I need to find all the movies that are directed by John Lasseter. So for this, I'll write select title, director, year from movies. Oh, we don't even need year. So we need only the title and director from the movies, but we need only the movies that are directed by John Lasseter. For this, what you're going to do is where director is equal to, you just copy that and paste his name over here. So you will obviously get all the movies that are directed by John Lasseter. So you need to write where director is equal to John Lasseter. And make sure that because this is a string is nothing but a collection of alphabets. Because this is a collection of alphabets, his name is a collection of alphabets, you need to put the inverted commas or the quotation marks, right? So when you put that, you will be getting this. Now let us go to the third question. Find all the movies and director not directed by John Lasseter. If you want director not equal to, not equal to, so not equal to is a symbol of exclamation and equal to. So if you have to write not equal to in math, right? So how would we write? So we usually write by saying like this and then here. But when you're writing in coding, not only in SQL, in any other language, you will be writing an exclamation mark equal to. So they both resemble, or they both signify only one thing, which is not equal to. If the director is not equal to John Lasseter, that means I'm getting all the movies that are directed by not John Lasseter, that are directed by other directors other than John Lasseter. Now, last movie you have to find all the wall movies. So where title like wall percentage. I got both the movies. Wall E, I know Wall E, but I don't know Wall G. Let us see when it got released or when it is getting released. Okay, so this is like a fictional information that we have here because Wall G clearly it's going to release in the future, that is 2042. Okay, so select title, director, year from movies where title like Wall and this percentage symbol is like just a comparison. So you go up and you read about percentage, then you will understand what this is. Used anywhere in the string to match the sequence of zeros or more characters. And you can only use this with like or not like. You cannot use it with any other statements. Now, by this, we will be completing our third chapter. And now let us go to the chapter 4, filtering and sorting queries. So remember, I was talking about cardinality, and cardinality is nothing but finding the unique, distinct elements, not the elements that are being repeated, but you are actually going to combine the elements that are being repeated to one single element. And that keyword is called distinct. And we'll be using this distinct keyword in solving the next 4 questions. Here you also have other conditions, like one is ascending order, descending order, and you can group them, you can order them. You need to order them for some of the questions, and let me write all the things that you'll be learning in 4.4. The keywords that are necessary for you to understand and write are, so let me write down the heading as keywords. In for filtering, grouping, filtering and grouping. So this is the lesson name, filtering and grouping. So for the first one is distinct. Next one is order by. Order by, you have two options. The first option is ascending order. It's called ASC or ascending order. Ascending order is it starts from small number and it moves to the large number or larger alphabet. The opposite of this is descending, DESC. Descending is you start from larger number or larger variable and then you go towards small. So that would be your direction. We know this. What is ascending in order and descending order? Next one is group by. And the fourth one is limit and offset. So you'll understand limit and offset when we are actually doing the third and fourth example. So just take this down and then let us go and solve some of the problems. List all directors of Pixar movies without duplicates. So I need to list all the directors of Pixar movies. So select directors from movies. But here, if you see, I did not get the tick mark. That means my answer is not right. So John Lester, Pete, John, again, John. I have John Lester at least 3 or 4 times, and I have Pete at least 2 times or 3 times, and I also have Andrew 2 or 3 times. But to find out the cardinality of this set, so this is a set because this has certain number of elements, right? And your attribute is director and your entity is movies. But from the entity movies, from the attribute director, I need the cardinality function. That means I don't need any repetitive director names. I need only the distinct director names. So if you scroll up, you see that select distinct column. I need to write distinct director. And the moment I click enter or space, so it will give you all the directors names, but and there are no duplicates. But the thing is, they are also asking alphabetically. So I need to write A, B, C, D like that in the alphabetical order. So for that, I need to write order by ASC. What are you ordering by ASC? Order director by ASC. Hold on. Okay, so this is a mistake I did. Order by director must be in ascending order. So you see that it starts with A, B, then D, J, L, P. So that is an alphabetical order. So that's what you need to do. It's not order director by, but you have to write order by director ASC. So now you have completed the first question. So let us move on to the second one. List the last 4 Pixar movies ordered from most recent to the least recent. Last 4 Pixar movies. So we need select title, comma, year, right? But we need the last 4 movies. So the most recent to the least recent. So we need to write order by year. If you want to write the order by year and the most recent, so the most recent would be 2013 and the least recent would be 1995. So we need to write this in the reverse direction. That means the most recent should come up and the least recent should go down. So for that, we are not going to use the ascending order, but we are going to use the descending order. Right, order by DESC. So you see that Monsters University started in, it released in 2013, and then the first Pixar movie is Toy Story, and it went to 1995. So this is how you get that. But the answer is not done, because list the last 4 Pixar movies. We need only the last 4. That means we need 2013, 12, 11, 10. So I'll also write, let us write ID. Okay, we don't need ID, but what we will do is, instead of writing this, we will add one more new function by removing this, and then limit. We need how many? We need only 4 Pixar movies. The last 4 Pixar movies. The moment I click 4, you will see the tick mark. That means your answer is right, and you got the last 4 Pixar movies. So try this out by yourself. Now, the next question is, list the first 5 Pixar movies sorted alphabetically. The first 5 Pixar movies sorted alphabetically. So first you need to sort all the Pixar movies alphabetically. Title, comma, year. I'll take director also this time. Title, director, year from movies. Order by title, order. So now you have A, B, C, F, M. It's all in the alphabetical order, right? And finally you have W. But here you need only the first 5 Pixar movies. So I'm going to write limit 5. The moment I write limit 5, you got the answer for the first 5 Pixar movies. Now, you don't want the first 5. In the fourth question, you don't want the first 5, but you want the next 5. That means your order should start from 6, 7, 8, 9, 10. So that is what we want, right? To get that, you have to use another keyword. It's called offset. So you need to read this sentence. Another clause which is commonly used with the order by clauses are limit and offset, which are useful for optimization to indicate to the database the subset of results can be you care about, like whatever you want. The limit will reduce the number of rows to return, and the offset will specify where to begin. So we need to begin at number 6. So I'm going to limit 5, offset, we're going to start at 6. Oh, if you start at 6, the problem is you're going to ignore the 5th one. So you're going to go 5, 5. When you write limit 5, offset 5, that's when you're going to get all the 5 movies that are starting from number 6, 7, 8, 9, 10.
Time to start your day.
Hold
Good
on.
morning.
Alexa,
7 scored.
stop. So if you remove this limit 5 and offset 5, So you will see all
Good
the
morning.
movies, right?
Seven score and
Alexa,
17 years ago.
stop. Sorry about that. So yeah, so if you don't write limit and offset, you will see all the movies. But here we don't want one, two, three, four, five, but we need the one that is starting from six. That is from Monster University, Monster Inc. This one, The Incredibles, and Toy Story. So these are the five movies that we need. So for that, we'll write limit five. When we write limit five, the first five movies is something that we are going to get. But we need to also write offset 5 that will give you the next 5 movies. So with this, we'll end today's tutorial, and then in the next class you'll be learning about what is a union, what is an intersection, what is a complement, and then we will be also learning about simple select queries and multi-table queries with joins. So from here the complexity of databases increases slightly, but I'll try to make it as simple as possible for you by understanding both Venn diagrams and also taking down some notes on databases. And I want you guys to practice exercise 1 to 4 before we jump to lesson 5 or exercise 5. Okay? If you have any questions or any doubts, leave a comment or ping me on Hangouts or write an email to me. I'll be more than happy to help you guys. And you can also always review the lesson 1 to 4 from the videos that you already have, and that will help you in actually solving a lot of problems. Now I'm going to stop the recording, and I'll see you guys in the next class.